let's take a moment and recall what we mean by solving an equation. To solve an equation means to find all of the solutions, all of the values of the variable that make the equation true. Now, as we progress through algebra, we will come up with many solution strategies. The one that we're talking about in this unit is just the simplest one. The solution strategy that we're going to choose for linear equations in one variable is to manipulate the equation to obtain an equivalent equation of the form the variable just equals a constant, which has exactly one solution, exactly what it says there. Since this is equivalent to the original equation, we then know that the original equation has exactly one solution. And remember our tools for manipulating an equation. We can add the same number to both sides, or we can multiply both sides by the same number, provided that number is not 0. Alright, so there are several forms that a linear equation in one variable can take. We're going to think separately for a moment about how we solve each one. One of the simplest forms is the form a number times the variable equals another number. Some examples of equations in this form: 2x equals 6, 2/5 t equals 8/3, negative 21 equals negative 7y. Notice, this equation is still of this form by the symmetric property of equality. Right, this means the same as negative 7y equals negative 21. 0.4p equals negative 7. There are all sorts of examples of this form. And our goal in all of these cases is the same. We want to end up with an equation of the form our variable equals a number. Though, in this case here, I think it's going to be easier to get to the point where we have y on the right, which is totally fine. So the question is, how can we accomplish this goal using one of these steps? Well, remember that just the variable by itself really means 1 times the variable. So we want to change things so that we're multiplying our variable by 1. Well, we know how to accomplish that. Right? We'd like to multiply 2 by its, what is it that we call the number that when we multiply it by 2 we get 1? Oh yeah. The multiplicative inverse. We'd like to multiply both sides by the multiplicative inverse of this coefficient. Now what times 2 gives me 1? Right, that's the reciprocal of 2. Right, so 2 means 2 over 1. Take the reciprocal and I get 1/2. I'm going to multiply the left-hand side by 1/2 and the right-hand side by 1/2. And I'll get 1/2 times 2, that's my 1, x, equals 1/2 times 6, that's 3. I get x equals 3 as my solution. Now I'm going to quick check. 2 times 3 equals 6. Yes, that works. Okay. Here, finding the multiplicative inverse is actually a little bit easier, right? 2/5, take the reciprocal, it's 5/2. So I'm going to multiply both sides by 5/2. 5/2 times 2/5, that's 1. 5/2 times 8/3, You're welcome to use a calculator for this if you'd like, but it's 20/3. So I get that my t is 20/3. Checking. 2/5 times 20/3. I'll see a common factor of 5 cancel, and I will indeed get 8/3 as I hoped. Alright. This equation, I need to take the multiplicative inverse of -7, right? Remember, -7, that's -7 over 1. Its reciprocal is 1 over -7. So I'll multiply both sides by 1 over -7. 1 over -7 times -21, that's going to be +3. Remember, 1 over -7 is a negative number. And that'll be equal to 1 over -7 times -7 is just 1. So that's 1y. I get 3 equals y, which means the same as y equals 3. Checking. -21 equals -7 times 3. Yes, that checks out. Okay, last equation. I've just moved that over to get a little bit more space. Working with that decimal is a little bit screwy. We could easily work way too hard on this. I'm just going to write my decimal as 0.4 over 1 and say that its reciprocal is 1 over 0.4. And then I'll do decimal arithmetic at the end, or just use a calculator. So I'll have 1 over 0.4 times 0.4p equals 1 over 0.4 times -7. So again, 1 over 0.4 times 0.4 is just 1. So we've got 1p. 1 over 0.4 times -7, that's a job for a calculator. I'm just going to take 1 over 0.4 times -7, and I get -17.5. So my p is -17.5. Checking. 0.4 times -17.5. Right. Calculator again. 0.4 times -17.5 really is -7. Notice, whenever you've just solved an equation, you can go back and plug in to make sure that you've worked correctly. And in fact, that's a good plan, especially when you're working with equations a little bit more complicated than this. You can always be 100% certain that your answer is right when you've just solved an equation, just by going back to the original equation and plugging in to check.